Number 10 on page 154. So you have a cosine curve. And I technically, I said you rotate it to form two shapes, but it actually is three in total, although that doesn't change what I do.
Yeah.
Can I just have a pen to mark to remind myself to change that? Okay, thank you. So anyways, the idea is we spin that around. So the answer is volume is pi 0 to 2 pi cos squared x dx. Now, did you do question 9?
We have to go to that.
Yeah, yeah. Because if you get number 9, then you get number 10. Or if you get number 10, then you can get number 9. So, okay, let's calculate this. This is pi 0 to 2 pi cos x dx. So this is pi. And we can use the by parts formula here. So f is cos x, f derivative is minus sine x, g derivative is cos x, and g is sine x. So this is f g minus integrate f derivative, which is minus sine x, g, which is sine squared dx, like that. And everybody has limits here, 0 to 2 pi. Yeah. Now, just to make my life easier, I'm just not going to write the limits, and I'll just put them in at the end, okay? So, v equals pi. No, let me be clear. Pi integrate cos squared x dx equals pi cos x sine x plus pi integrate sine squared x dx. So what do I do next? I want to continue with this integration. What do I do next? I'll have to use by parts again on sine x, sine x. Although there's a sneaky little thing I could do here to save me doing that. Yeah. If I change the sine squared into 1 minus cos squared x dx. So this is pi integrate cos squared x dx equals pi cos x sine x plus pi integrate 1 dx minus pi integrate cos squared dx. So we can take that to the left and we'll get 2 pi integrate cos squared x dx. That's equal to pi cos x sine x plus pi integrate 1. So now I divide by 2. And what was this? This was the volume. So the volume will equal pi over 2 cos x sine x, and then we have to put in 0 and 2 pi. And I know that works out to be 0. Then it's plus pi over 2, and then integrating 1. It's x, and then 0, 2 pi. So I put in the 2 pi, the 2's cancel, and I'm left with pi squared as my answer then. Okay. Wait, why are you guys so late? It's like 8 minutes past. Why are you so late? So what? I don't care. I'm marking the two of you as absent for this hour.
What, you took the absent?
Yeah. In my head. You know, it's only 1 hour, so when you're... Okay, whatever. Just sit down. Sit down, sit down.
Sorry.
Where is your house anyways?
Here it is. Yeah, this is
Do you get lost coming back to school?
It's sunny today.
Yeah. Right, answer is pi squared. Okay,
Sir, can you explain why you said that these equals?
what, the first one?
Yeah, it just cancels it. Why?
Yeah, because I know that when I put in 2 pi and put in
Okay.
0, I get 0 and 0.
I understood immediately.
Right, Mo, what's the next one?
Page 152. 4A.
4a. Didn't we do this one in class?
We?
I think we did. Didn't we? 4a on 152. 4a.
Yeah,
Or
we,
A.
sorry, we did it.
We did that in class. I think we would like to do it after lunch. I think the idea was we can do it in the class at 4. Yeah. From past papers? Yeah, we can do that at 4. Yeah. Okay, what's next then, Mo?
I think that's it for me.
Just one question today. Oh,
Just
okay.
two.
You're getting better, so. Alright. Who else now? Yeah. Same page number 3. Yeah. Which one? Will we do C? 3C? Wait, what page? 150? Oh, 154. 154. Yes. Number 3. Yeah, okay. Let's have a look at that. Can I scroll down? 154, number 3. So you're integrating from 1 to 2, 1 over x squared dx. One common mistake students make in the exam is they say this integrates to log x squared, which doesn't. So what you need to do is you need to change this into x minus 2 dx. Because 1 over x is x minus 1, and squared minus 2 then. Okay, so what does that integrate to? X minus 1 minus 1 over minus 1. Increase the power, divide by the power. Then we have to put in our 2 limits. So I'll put in 2 first, sub it in, and you get minus pi over 2. Then you sub in 1, and you get pi. Right? No, I did something wrong. Minus minus, yeah. So you put this in on your calculator and you'll get pi over 2 is the answer then. Yeah. Right, what else now?
Yeah, 156, question number 2.
Really?
Yes.
Really?
Yeah.
Okay. For real? Okay, for real. Right. 2x squared plus 6x plus 5 over x cubed plus 5x squared plus 8x plus 4. Now, what are the factors there of that cubic? X plus 1
X plus 2.
and x plus 2. And you have to decide which is the repeated one. And it has to be x plus 2 is repeated. Yeah. Because we need to get a 4 in our answer. So we know that the first guy is going to be definitely x plus 1. The second guy is definitely going to be x plus 2. And the last guy has to be x plus 2 squared. Now, this is where you have some choices. You can go with A, B, and here two constants, the top must be one constant. It's quadratic, so it should be linear.
CX.
So it could be C, X, but it could also be D, possibly. Yeah. So we can go with CX first. Okay.
Sir, online everywhere I look, they always put CX plus D.
Yeah. Yes, that's what I used to do when I was first teaching this. But I discovered that one of them works out to be 0. So we'll do it. We could have this, okay, or we could have CX, or we could have D by itself.
What D, but you can have D just if X equals 0.
Yeah, if C equals 0. So in other words, Mo, if you include both, then you've considered, the two possibilities. So really it comes down to this guy here. You have a couple of things you can do here. You could try just CX, just D, both, like that.
But if
Okay.
you know that X is not equal to 0, so it can't be.
No, we can. This is, it's fine. Now, the other possibility though, is you might think to yourself, well hang on, I could make a tiny, tiny change here. I could say this is A over X plus 1 plus B X plus 2 over X plus 2 squared plus CX plus D over X plus 2 squared. Yeah? Now these two denominators are the same, aren't they? So you can put them together as A over X plus 1 and is a linear plus a linear. So what would you have on the top in total? A linear. So that would be EX plus F over X plus 2 squared. Which you realise is already this guy. So I think, Mo, if you opt for this, which you say a lot of places do online, then they must not include this. Because that can be included in that. So now we have 4 ways we can think about it. Okay? So let me just put them, what I'll do is I'll just separate them out here 3 ways. So the first one is A over X plus 1 plus B over X plus 2 plus CX over X plus 2 squared. The second way is this guy can get included in that, which is A over X plus 1 plus, we'll just say, B plus CX over X plus 2 squared. But that's different B and C, of course. And the last one, A over X plus 1 plus B over X plus 2 plus, I think we could have C over X plus 2 squared. But I would be least confident about this one. I know from using my 3 guidelines that this guy will definitely work.
Yeah.
And this guy just can be rearranged from this guy. So I know that this will definitely work. I suspect that I could just have a C here. So I think this could work. Yeah. Now, do you need me to continue with actually doing each of the 3, or what's the story?
I just messed up with the third X. I don't know if I got A, and I got C. I just need, I don't know.
Well, you'll perhaps you use which method?
Second one.
Second method for each of these. Okay. So we need to make our equations here, if I can. So what do we multiply everything by? The X plus 1 and the X plus 2 squared. So here's our 3 situations. I'll just make myself a bit more space here. Okay, so let's try and get the first one in our heads. If we multiply by the cubic, so I'll call this answer alpha, beta, and gamma. Okay, so let's look at answer alpha. We get 2x squared plus 6x plus 5 equals. Now, can we try and multiply this out in our heads? We're multiplying by the cubic. So what would the first one be?
X plus
A times,
X plus 2
good, plus
B times X plus 1 and X plus 2.
B times both of them, yeah. And then lastly,
C is just X plus
Cx times x plus 1. Okay, now, what I'm going to do is just open this program up so I'm not having to... Right, okay, so before we start subbing in, let's think about what we should sub in. So firstly, I could choose x equal to what to get started? Minus 2 would be good because then I would get C.
-1.
Okay, next x equals minus 1 and that would get me
A.
A. And then lastly,
0.
0. Yes. And that would get me B.
How?
This guy goes, true?
Yeah. Yeah.
This one just becomes 2B.
Yeah, that's right.
So that, and this guy will become 4A, which we have.
Yeah.
Oh,
Yeah?
so stupid.
No.
Yeah, I get it.
Trust
Yeah,
me.
Sorry.
Right. And then we can get the C, A, and B then. And then it's the same thing for the other two. Yeah. So let me see. Let's see if I can try and have both on the screen here. So if I could. Right, so let me just write this out. 2x squared plus 6x plus 5 equals A x plus 2 squared plus B x plus 1 x plus 2 plus C x x plus 1. Okay, what do I sub in first, did we say?
Minus 2.
Let's sub in x is minus 2. And if I simplify this, I get, and solve it, so actually I should have just, C is a half. Great, okay. Now, what did I sub in next?
Minus
Minus
1.
For x. Simplify, and I get A is 1. Good, and what do I sub in?
C.
0, lastly. But we have A and B, but we already know A. A is a half,
A is 1.
isn't it? No, sorry.
A is 1.
A is 1.
And C is
So I can get B now. So B was a half. So C is a half, A is 1, and B is a half. Let me check. Yeah, that checks out. Do you need me to do the other ones or not, Mo?
No, I'm good.
You think you got it?
Yeah.
Okay, good. Alright, what else do we need to see now? Yeah.
Page 154.
Go on.
Does 11 and 12 come in exam?
Yeah.
I just don't understand why then we need to rotate the form.
Which part?
12A.
12A. Yeah, what would you rotate to make a cone? Yeah, but a certain type of linear, not just any linear.
increasing.
Yeah. So Amjad, for that question, to make a cone, you would have to rotate a line that passes through the origin and goes to the point HR. Because when you rotate it, this will represent the height of the cone, and that will represent the radius. So if you rotate the line 0, 0 to HR, you will make a cone of height h and radius r. Yeah?
How do we know what the radius?
No, I'm keeping it general. And we can see in the next part it says, what would the equation be? And I'd say radius r and height h. They're usual letters for radius and h. No, there's no number answer here. Your answer will be in h and r.
Okay.
Yeah. No number answer here. So, for example, what's the equation of this line? It's y equals mx plus c, but the c is 0, so it's mx. What's the m? It's r over h, x. So the volume is 0 pi, 0 to h, r squared over h squared x squared dx. Right? Yeah?
Okay.
Which is pi r squared over h squared x cubed over 3, 0 to h, which is pi r squared over h squared h cubed over 3, which is 1/3 pi r squared h.
That's
Yeah, I know. It's funny.
Mm.
We've proved it. Okay. What we got next? What's next?
So in the back for the last question, I got the second part and the third part. The first part, because you said 3 different answers. The first part was which one that you showed us?
The first one was where they're all constants on the top.
Oh, okay.
Guys, can you just go and look at the last question on 156? We were just doing it a minute ago. So if you go to the back, there are 3 different answers. I just want to show you that those 3 different answers, they work out, okay? So the first one was 1 over x plus 1. What's next? Plus 1 over x plus 2 minus 1 over x plus 2 squared. Okay, I'm just going to do simplify basic and I end up with that. Isn't that what we had?
Yes.
That was it in the question, wasn't it?
Yeah.
Yeah, so that story checks out. Right, let's look at the next one. 1 over x plus 1 plus a half over
X plus 2
x plus 2
plus half x over x plus 2 squared.
x plus 2
Squared.
squared. Okay, so let's simplify that again. Add it together and it simplifies to that. Again, even though the answer looks totally different, doesn't it? It looks totally different. It does simplify to the original. Right, the last one was
1
1,
over
yep.
x plus 1 plus x plus 1 over x plus 2 squared.
That's that one. We add that together.
We get the same thing.
Yep.
So
So,
that's
so what I'm saying, Mo, is with these partial fractions questions, there's a little bit of flexibility. Now, if you look at the 3 answers at the back, not all 3 answers are useful. Or what I mean is, there's a preference over which one you would prefer to use. So if you look at those 3 answers, which would be the more preferable one?
Third
Why?
one. Because if you want to integrate that one, it's easier, isn't it?
I don't think it is actually.
true.
I think of all of them, the first one is the easiest form. Because they all have constants in the numerator. And they would be easy enough to integrate.
Can't we find the
Just
x?
by parts.
You could use by parts, but I think the quickest one would be the first one. Because you could just use a substitution. The first 2 integrate directly to log, and the third one you just say u equals x plus 2.
Yeah,
Yeah, substitution. Yes, MJ, what were you saying?
Can't we find x in the second and third one?
What do you mean find x?
Substitute it with half x.
No, we talked about this in class. These are not equations, they are identities. Do you remember?
No.
What do you ask me? Can we find x in the second one?
Yeah, because we have x.
We have x. What are you talking?
No, we can't get X from the first.
Can we? How can we get x? My
It's like,
question isn't equal to anything. Do you know what I mean? Like, it's not equal to anything. I need at least an equal sign. No. It'd be like, to me, Amjad, it's like saying x plus x equals 2x. What's x? You can't, it's not possible.
what is
X plus x equals 2x. Can you see? X plus x equals 2x. I can't get it.
I thought no was equal to 0.
No, not equal to 0. No.
Sir,
Yes.
can you show how to get the first answer though?
In which one?
In question 2.
Okay, let's see. I don't think that would be too bad. Can I go back? So it was a over... Well, I'll just type it out here. A over x plus 1, yeah?
Yeah.
Plus b over
X plus 2
plus 2 plus c over x plus
2 squared.
2 squared. And we wanted to get the A, B, and C. Now, I think the second method would be best here. Yeah? So we'd have to multiply all of this by the usual story here, which is x plus 1 and x plus 2. In fact, that's nearly like what I had up here. The only difference is no x here. So I'm just going to edit this and delete that x. Right, okay. Everything else is the same. So what would I sub in? I'd nearly do the same things, wouldn't I?
Yeah.
Let me just delete all this. Right guys, look at this. What would I put in first for my first value of x?
Minus 2.
Minus 2. Sub in minus 2 and I get... If I sub in minus 2, what can I get? I can get c. C is minus 1. Okay.
Something minus
Sub in now, x is minus 1. What would that give me, Amjad?
1.
That would give me a. I should be able to get the a out of that. And I do. Okay.
So it's just because
Yeah.
we are changing the
Uh,
way we write out the equation
yeah.
that we're getting the 3 different
Let me
answers.
just, put in 0.
And A is 1.
And then I have a and c. I have a, b, and c. But I can sub in a
To get B.
and c. A and c. So a we said is 1. And then c we said is
Minus 1.
minus 1. And now I can solve this. B is 1. So I got 1, 1 and minus 1, which is what I have there. And we know that works because I showed you that it adds together. Yeah. Okay. What's next now? What else have we been doing recently? What about the by parts question 5?
This one's easy.
Is it? Did you get it right?
Yeah.
Okay. I'm going to do it because I saw a question similar to that come up on the exam from time to time. Page 152, question 5. So I ask you to integrate x over x squared plus 4x plus 8 dx, and I ask you to think about it as a by parts problem where you have to integrate x times 1 over x squared plus 4x plus 8 dx. So if I was to use my formula, f is x and f derivative is 1, yeah? G derivative is 1 over x squared plus 4x plus 8. So what's g? So now we have a new side problem. We have to work out what the integration of 1 over x squared plus 4x plus 8 is. Who remembers what to do here?
Factor.
Factorize first.
Completing
No factors for this.
X squared is 4x plus 8. Power minus 1.
Oh goodness, no.
completing
Completing the square, yeah. This is 1 over x plus 2 squared plus 4, which is 2 squared. And we have to use a substitution here where we say let u equals x plus 2 over 2. So that means du dx equals a half. So that means dx equals 2 du. So my question gets transformed into integrating 2 du over x plus 2 squared, which is 2u. So that's 4u squared plus 4. So that becomes, cancel out the 2's, 1 over 2, integrate 1 over u squared plus 1 du, which is 1 over 2 tan inverse u, which is x plus 2 over 2. Goodness. Right, so now we can go back here and say the integration is 1 over 2 tan inverse x plus 2 over 2. So now we can use our by parts formula, which is f g plus f derivative g, isn't it?
Yeah.
Goodness sake. You see, I didn't think it was that easy. Now we have to continue. But we have a new problem. We have to integrate this. Yeah? So how do we integrate this? Well, that's a new side problem. Can I go to the side?
Yeah.
So let me just integrate, what was it, a half tan inverse x plus 2 over 2, wasn't it?
Yeah.
Well, I should use a substitution here. What substitution should I use?
X plus 2 by 2
Over 2. So what does du dx equal?
x.
A half. Yeah, so what does dx equal? 2 du. So this becomes a half integrate tan inverse u 2 du.
Yes.
Cancel, cancel. So now I have to integrate tan inverse u du. How do you do that?
1
One
with
over-
the product 1 plus x squared.
Yeah, 1 over
No,
1 over 1 plus.
no. Oh, well, we have the result, don't we? But it's,
It's 1 over.
1 plus x.
No, that's the
square
der-
plus 1.
no, that's the derivative of tan inverse.
Oh, yeah.
So, well, I showed you how to do this in class. We have to use by parts where you put in a 1. 1 tan inverse u du. So now, another by parts problem. This is, f is, no, do I have that backwards? Sorry, I have my 1 in the wrong place, don't I? Tan inverse u times 1 du. Right, so f is tan inverse u, and its derivative is 1 over u squared plus 1, and this is 1, and its integration is u. Yep. So this becomes u tan inverse u minus integrate f derivative, that's u over u squared plus
Is it 1?
1, isn't it?
1 over.
Minus
Oh, yeah. yeah.
f derivative g
Multiplied by u.
du. Is that right?
Yes.
Right.
Plus.
Now, I have a new side problem. Integrating u over u squared plus 1. Can you see why I was suspicious that you said you got it? So, how do I integrate this?
Again.
How do I integrate this? No,
Completed this part.
not this time.
U into 1 over
Yeah.
Let v equals
Square.
u squared plus 1. So dv du? dv du? 2u. So du is
dv over
dv.
dv over 2u. So that goes back in. Integrating in u over v, dv over 2u. Cancel, cancel. Integrating 2 over v dv, which is,
Log V.
minus 1.
this is right. Oh, sorry, I have my 2 in the wrong spot, thank you. 1 over 2. So this is
2
Log V.
1 over 2 log v. Right. So, have you seen that movie Inception? Where they're in the 3rd level, and then you have to start snapping back up a level. So,
So these.
yeah, we have here a half log v.
But we use.
We wake up from this dream, go up to the next dream. That's a half log
U squared.
u squared plus 1.
Go
Then we
back
wake up from that dream,
sideways.
and yes. So let's see. This here is u tan inverse u, but u is x plus 2 over 2, tan inverse x plus 2 over 2, and then this guy is minus a half log u squared plus 1, and u squared is x plus 2 over 2 squared plus 1. Then we wake up one more level, and that goes back in.
They really
There.
did this.
No, they didn't, I'm just joking.
Yeah.
So we have x plus 2 tan inverse x plus 2 over 2 plus that thing, which is that there.
You know, this looks like in the movies they have those 3
It
balls
does
and
look
the-
exactly like
the-
that. Yeah, don't worry, you'll never get that in the exam. Yeah. So Mo, you got this answer?
I don't know how.
Thanks to the September 27th
I
students.
think I did something horribly wrong, and then
Yeah,
I somehow got the right answer.
I don't know why I have 4 delta x in there. I think that's a typo. It must have been 4x just. Yeah. I'll have to fix that. Can I have the pen, please? Now, yes, you have a little note on the back.
I was going to ask
It says, thanks to September 2017 for this.
how did they even find the question?
Which one? Yeah, how did this question come about?
This was 2 years ago.
I'm trying to think.
It's 1 year.
No, 1 year ago.
2x. Yeah. It's okay. So we just did this question, x over x squared plus 4x plus 8 dx. I think what happened was we were looking at this question in class. Now this looks very, very similar, doesn't it?
Yeah.
Yeah, where this one we just did was very hard. This one here was actually very easy. Even though there's only one tiny difference between the two.
Yeah.
What's the only difference?
That's
Constant.
This plus 2.
It simplifies.
This makes it hugely much easier to do because this one you can now do as a substitution in one step.
Yeah.
And you get du dx equals 2x plus 4, which is also the same thing as 2 times x plus 2. So what will happen is when you sub that back in, it will cancel and you're left with 1 over u,
Okay.
which is just log u.
Log
So, you know, this is like 100 times easier than this. But the only difference between the two is this plus 2. And this is what I'm saying. It's not always clear what you're about to do will be easy or hard from just looking at it. Because you might think, oh, they're pretty similar, so they should be about the same difficulty. Well, not, clearly not the case here. Yeah. Oh, yeah, let me actually type this in. Can you read it out? What was it? X over
X squared plus 4x plus 8
x squared plus 4x plus...
8 dx.
Yeah, so we want to integrate this. Yeah, so that delta in the answer shouldn't be there. It's just that. Yeah, so you can see how handy it is having math software. Because that program just did everything we did to get to this answer. By the way, A tan is just tan inverse. Right, okay.
Even a short question on that, can you do? Just like what?
Go on.
Tan inverse,
Integrate, yeah.
tan inverse.
Yeah.
Over 1 plus 1 over x.
Tan inverse what?
Just
No, tan inverse of what? Yeah, there must be something in the tan inverse.
X.
It can't just be tan inverse like that. You saying it's like that? No. No, it couldn't be. Show me it. It's right, what is it? Tan inverse.
yeah, 1 over. Not over. Over. Yeah, 1 plus 1 over x squared dx.
But what's he here?
Has to be X.
There has to be something there.
Giving me cot.
Two
No,
over x.
tan inverse as in 1 over.
It's your question.
2 for x.
But even then there should be something.
No, it doesn't possible.
I'm not going to do this unless you're sure that this is a real question and you have it right.
No, I'm sure it's a real question.
No, you're not sure. Everybody heard his silence when I said what goes here. I don't know about that now.
Yeah, it's x.
Right. I think we want to change this as 1 plus 1 over x squared. Like that. Tan inverse x. And we want to integrate this.
No, the other way.
How do we
Sorry, you're right. Li. Like this. Okay. Right, so let's make our table. F is tan inverse x. F derivative is 1 over 1 plus x squared. Now, is it 1 plus 1 over x squared, or is it 1 over 1 plus x squared? Do you know what I mean? Is it one fraction or two here?
No, it's 1 plus 1 over x.
It is like this.
Yes.
Yeah, okay.
Sir,
F derivative, yeah?
how did you get it like this from there?
Oh, sorry. Sorry. It's
Over.
1 over that.
Yeah.
Ah, yeah, okay, so that means here I have 1 over 1 plus 1 over x squared, and here I need the integration of that.
Yeah.
So let's integrate that.
Okay, you could simplify that fraction.
Yeah, well, I'm going to simplify it before I integrate it. So you can simplify that fraction as x squared over 1 plus x squared
Yeah.
dx.
That works.
Yeah.
Then you have to
Not a substitution.
That works.
Might be by parts again.
But which is F, which is what is G? They're both.
I think you might make x squared the numerator and 1 over 1 plus x squared the denominator, because that would produce an integration of 1 over 1 plus x squared, which is tan inverse. So I think you could get a tan inverse here. I think this one will take a little bit of time to do. We'll do this one. We'll do this one after lunch. Yeah. I think this will be a good one to try. Yes. Yes. And then we'll have a look at some exam questions. Okay? Yeah. All right. We'll leave it there.
It
So.
goes into 3 levels after this. Yeah.
I can see
Doesn't
something. I can
simplify.
see. It might end up being a loop.
Yeah, it doesn't simplify.
Yeah. So it might end up being a loop, and we'll have to break the loop by bringing it back to the other side.
Oh, okay.
We'll see later. He's just being a jerk. That's all.